we did last time.
I think you're wearing white shirt.
Tottenham Days, Halacha Gimel and Daled. Gimel and Daled, which was Gimel and Daled was about that you Kalim are not allowed to touch each other. They're not allowed to touch each other during the Kashering. So the simple
What did he say?
We did Halacha Gimel and Daled.
Yeah.
That Kalim are not allowed to touch each other during Kashering.
No, they're not heavy. I mean, they would touch.
Well, that's what we talked about.
There's one period they don't touch.
That's correct also. But that's what we talked about last time, what it means to touch or to not to touch. Okay, and the simple example of that for an average consumer is, the average person is if you run a kasher, a big container full of silverware, so logically a person would just say, take this and we'll just dunk them into the pot, and that you can't do. You have to put them one at a time. Okay, that was and we took last time.
The first experience, I started working at CRC. It took me thought, I was going to come to the mountain. I was here for a week. I wasn't really working. I'm a brilliant Yaakov Kasher, take this big potato bag, fill it up with silverware, and put it into the water. One second.
Okay, so that's what we talked about last time, is why the dinner is like that, why you are not allowed to have them touch each other, and which cases you are, etc., those kind of things. Okay? Today I want to talk about a piece of equipment where you'll see, as we get to it, that the shiloh has to do with this thing, and that's the only connection that has this thing, but it is a worthwhile thing just to understand this piece of equipment. It's not something you hit every day of the week, but if you will, just understand what it is. And what we're talking about is a distillation column. Okay? A distillation column means you have two liquids that are mixed together, okay, so in some form, two liquids, and you want to separate parts of those liquids one from the other. So you distill those liquids, and this distillation column helps you separate those liquids one from the other. Parts of the liquid to undilute them from each other, so to speak, and turn them into two separate things. The example we're going to use, just for the simplicity of it, is flavor essence, which is to say, when you have apple juice and you concentrate, let's say apple juice, you concentrate it, what happens is you're basically boiling water out of the juice, leaving the concentrate behind. With that water that boils out goes the flavor essence. A lot of the flavor goes out with the water. So you now have concentrated apple juice, but it doesn't taste like anything. Okay, it looks like apple juice, but it doesn't taste very good. So what you do is you take that water that boiled out, it boiled out of steam, you turn it back into liquid, you cool it off so it turns back into water, and then you remove the essence from it. You get the essence out of it. So now there's water and essence mixed together, you get the essence out, and then you put that essence back into the juice. Okay, so the difference, after you make the concentrated juice, it doesn't taste good until you put in, a couple of drops of essence, makes it taste more like apple juice, like it's supposed to. Okay, so when you have this water that you want to separate, you want to get the essence out of the water. How are you going to get the essence out? So this thing called a distillation column, or in that case it's called an essence recovery column, but it's the same thing. A distillation column helps separate one liquid from the other. Okay, typically these things are very big. Okay, for an essence column, it might be 20 feet tall and 2-3 feet across. But in more sophisticated places, like for fatty acids, it'll be 100 feet tall and 5 feet across. This is a very large piece of equipment. Okay, when you pass one, it's usually pretty easy to find the plane because it's poking out. It'll be 50 feet tall. Okay, there's a long column. That's what it's called, a column. Okay, and it works under the following first some theoretical principles of what it works on. Okay, first of all, when you heat up a liquid, when you heat up any liquid, the molecules start moving around faster. And what happens is some of those molecules, since they're moving around faster, separate from the bulk of the liquid, and they rise off the top. Okay, if it comes to a boil, that there's so much of it coming off, it's just boiling off fast. If it's not at the boiling point, even before the boiling point, it's moving around so much that some of the molecules that are on the surface of the liquid will go away. Some of the molecules that are on the surface will just leave the liquid and they'll disappear. Okay? We call that evaporation. The rate of how things evaporate depends on two things. First of all, is the temperature. Meaning, if I take a bucket of water and I put it outside today, it'll evaporate, let's say, in 10 hours. Okay? Let's say in 10 hours it'll evaporate. If I take out that same bucket of water and stick it outside in January, okay, it'll take 2 days for it to evaporate. Even the same amount of thing, because at warmer temperatures, the molecules move faster, more of them are escaping out of the top, and they leave faster. Okay? The other thing that evaporation depends on is what's called surface area. The evaporation only happens from the place where the liquid is in contact with the air, the surface. So the more surface area there is, the faster it evaporates. So for example, if I take this bucket of water that takes 10 hours to evaporate when it's sitting outside, If I take that bucket of water and spill it over the floor, and I mop my floor, it'll evaporate in 15 minutes. Why? Because that same water at the same temperature has a surface area now going across the whole floor, so it's evaporating from all those places at once. If I have it in the bucket, there's only a few inches to evaporate from. If it's across my whole floor, it has more area, so it can evaporate fast. Okay? And the last understanding thing we need to know, a principle that we need to know is that in the case of, let's say, in essence, the way distillation works is that the boiling point of the two liquids, the two-part liquids, are a different amount. So in the case of the essence, if the water boils at 212, the essence might boil at 150. Okay, so we're going to take advantage of the fact that essence boils at a lower temperature. Meaning it escapes from the water at a lower temperature than the water does itself. Okay. So what the distillation column does is like this. It's going to take the water that you have and spread it over a huge surface. Okay, that's the goal. So spread it over a huge surface, and at the same time heat it up to exactly a right temperature where the essence wants to leave the water and the water doesn't move very much. Okay?
To be a degree higher?
I don't know if it's 1 degree, but somewhere, we don't need to boil it out. You just want to get it to evaporate out. So it could be something. Right, it could be depending on how much of a difference there is between the two temperatures, is how sophisticated your essence column has to be. If the difference in boiling points is 100 degrees separate, then it's easy to get them in between. If the difference, like in the fatty acids, is a very small amount, then you need a much more sophisticated piece of machinery that can get it just so at the right temperature where a certain amount boils off and a certain amount stays behind. Okay, so that's the chachma here, is to make it over a huge area, over a huge surface area, and at exactly a right temperature. So how do you get it to be a huge surface area? I told you it's 100 feet tall, okay, but 100 feet tall is still not going to give you the surface area that you want. So what you do is, you take this huge column that you see is filled with something called packing. Okay, that is to say, the inside is not an empty shell. The inside of that shell is filled with one of two kinds of packing. Okay, the one that we have here, this is called random packing. Okay, and what it'll be is, in each one there'll be only one size. Let's say this is the size, okay, and that usually that's 100 feet tall and that's 5 feet across will be filled 3/4 of the way with little pieces like this. Okay, a bunch of pieces, not one, 10,000 of them. They just pour them over the truck, they dump them in, just pour it in, and they're random. I mean, they're just a bunch of pieces. They're all just, in each case,
they're sitting here like a bowling or like the bowling that's plating.
That's correct. Yeah. No, in random packing, they're just loose. It's just loose. It's a whole pile of them. It's called a bed of packing. It could be 20 feet tall. There might be more than one bed of them, but there'll be just bed after bed of these things. And what's going to happen is that when you drip the water, when you pour the water through it, what's going to happen? You spread the water, you drip the water down through the whole thing. But what happens is the water is dripping over 1 million pieces like this. What's going to happen to it? It's going to break up into 1,000 tiny little droplets, because just by if you poured it just just poured it straight, it will go straight in one column. But by pouring it over 1 million little pieces like this, you're forcing it to break itself up into a zillion little pieces. Okay, so this liquid, when you pour it, basically pouring the water down over the top of it, but because there's these 1 million little pieces of Lego sitting in there, therefore it's spread into 1 million pieces, giving huge surface area. A drop of water is completely surface. There's no anything to it besides the surface. So you're giving the best chance for the liquid to evaporate out. Okay? And at the same time, from the bottom of the column, you send in steam coming up. Okay? You boil up steam from the bottom, or you boil the water as it drips to the bottom and it comes up as steam. So you're heating the stuff, this heat coming up, and the liquid is coming down, and what happens is this liquid splits into 1 zillion pieces. The steam is rising up to get to just a certain temperature, and in our case, the essence jumps over from the liquid to being in the steam. Instead of when it came in, the apple essence was mixed in with the water. After it drifts through all these pieces, by the time the steam gets past the bed, the essence is in the steam now. It's not in
water evaporated, so it's left over with that.
No, the water did not evaporate. The essence evaporated. The essence left the water. Mm-hmm. So the water is still dripping down, and the essence left it. So the essence has boiled off. The water's still going down. The water makes it only to the bottom. So it goes to the bottom. The water goes to the bottom, and if the bottom gets drained out, and the essence but left it, and where did it go? Then it gets mixed into the steam. Okay? And it goes out the top. What happens is the steam comes out the top. You catch that steam, you condense it, you put it against something cold, and it turns back into a liquid. So now you've had, instead of, let's say the original essence was 1% essence and 99% water, when it gets to the top, it's going to be 80% essence and 20% water. I mean, it's still mixed with a certain amount of steam. Okay, but you've now all of a sudden made something that's basically pure essence, as opposed to what was before was basically pure water. Okay, so you've got the essence out, and the water that's on the bottom is basically junk. There's just water left in it. Okay? Here's a artist's rendition of what it looks like. This is this is reasonably simple. The water comes in and it goes through a bed of packing. So that's what it's just through the bed of packing, and steam is coming up from here. The steam has contact over here, and then in this case there's a second bed, which is to say the steam that goes up here. Some of the essence that gets condensed went back in for a second run through. Okay, to help make it even more pure. Okay, and so there's 100 ways to set this up, but which in this case there's two beds. Okay, and by the time it comes out of here, what gets condensed over here is reasonably pure essence. Okay, so you get reasonably pure essence. Okay, in our case, we're talking about essence, but the same thing would be, let's say, in fatty acid place where they're doing it, they could have 10 different places where they take off steam. At every very specific temperature, they take off different things to get off what they call different fractions. So they take off different pieces of the steam. At just this temperature, they can get off the C8 will pull off it over here, and a little higher they get off a different temperature. At different places in the thing, there it's much more sophisticated, and the temperatures are much more finely controlled, and they pull off very specific pieces. Okay? Now the truth is that
it's not refined petroleum also, isn't it?
Yes, the same thing. When you want to separate one part of a liquid from the other, this is what you do. Sometimes they do the opposite. Okay? When they want to deodorize, they want to take the smell out of something. What they're doing there is they're taking the smell they're going to get to evaporate out. There, they don't want to catch the smell. They couldn't care less about that. They just go out the top. They don't care. There, what they want is the unsmelly liquid, the oil, that comes out the bottom. That's the more pure product. Okay, so in that case, what's going off, they don't care about. They don't try to save that. Maybe for the environment, they try to save it. But they're not saving because they want it. That deodorizer is the same thing, just the opposite. Instead of trying to catch what's leaving, you're trying to get rid of something so that you can have a more pure product. Okay? But the long and short of it is the same. Okay, so now this is one kind of packing. This is a common kind of packing. There's another kind of packing which is called structured packing. There's a picture over here, which is it looks like a car radiator. Okay, but it's the same idea, which is something with a million bends and twists in it, but instead of being random, they just put in 10,000 pieces. It's one unit that has in it all these, it's a corrugated piece of metal that has a million. Again, the idea is just to get the liquid to spread in 100 different ways around the thing. That's the point. When you're going to pour liquid over, it's going to spread into a million different ways. Okay. Now, the truth is, there's a third way to do this that doesn't use packing, which is it uses trays, and what that does is that as you go down, I'm doing back. As you go down the column, there's a tray here like this, and another tray like this, and then another tray like this. The trays stick out like teeth coming out from the sides, and the liquid pours down this way, drops onto this tray, and then rolls across and drops down to this tray. And again, the point is you're giving a nice amount of surface here, and every time it splashes, new parts get exposed to the air, and the steam is running up through all these, this like maze going up, and that's a different way of doing it, is through trays. Okay, now, we're now going to touch on why in the world it has to do with our day, which is, when you make, let me say, I'm sorry, before I get that, one more thing, which is, the packing that you see here is plastic, and here's one made metal, okay, but there are also people who use packing that's made out of ceramic, okay, and the reason is because these are more sturdy than ceramic is. The ceramic is very brittle, but ceramic can handle certain chemicals that these things can't. Once it's in, you could break it easily, but once it's in place, it can handle certain kind of more, I don't know what the word is, whatever, chemicals that would not go through a simple thing like this. So in those kind of cases, the Kashering, obviously we can't kasher those, because if the packing, the packing is made out of Kashrus, then you're not going to be able to kasher. Okay, and in fact, there have been places that have been that they find, well, what kind of packing do you have? Oh, they say we have ceramic saddles. A saddle is a certain shape, it's a shape. That's what the pieces are. They say, oh, we have ceramic, in which case, well, you can't kasher it. You have to change your packing if you want to be able to kasher in this place. Okay, but what our question is, for which I don't have a very good answer, which is like this: when you take these pieces of packing and you dump them into this thing, there's 10,000 pieces in there. Okay, they're all touching each other. Okay, the pieces are touching each other. Every one of them. That's the whole point. They're just a big jumble of Legos sitting in there. All the pieces touching each other. So the din is that kelim that touch each other can't be kashered, because at the place where they touch each other, there's going to be the hagol water is not going to penetrate that spot. Okay, now, the truth is,
that's the clinician over there, right?
it sure is. The steam rising up through the thing. It
has the one that has an outside steam jacket or whatever.
No, it doesn't have. But the walls are thick. It has a nice, heavy, thick wall.
How do they heat them up?
How do they heat? Oh, there's just steam coming up from the bottom. It's just like open steam lines just live pouring in from the bottom. Or
the product, the fatty acids or whatever,
right.
The juice or whatever,
they drip in from the middle or from the top.
Slowly in the steam?
No, it drips in at a reasonable pace,
okay.
But it eventually turns into a drip. I mean, just because of the way it's being broken up.
And what heats up that juice?
On the bottom, well, the juice might come in warm. It doesn't come in hot. But from the bottom, at the very bottom, either this live steam just shooting up the whole thing, or as the liquid falls onto the bottom, it falls into like a sump. It falls into a pool on the bottom, and the steam is heating that up, and it's boiling up.
Well, the second system clears the clear, the clean sub is heating it up. And the first case is not.
Why? You're pumping live steam?
Like the tank,
no, you're just pouring steam. The steam is pouring into it continuously, and the thing.
But steam itself is not a clearation.
Steam is it's like a fire. It's like when you say you have a steam jacketed kettle. Why is it a clearation? No, that's a heat source. The steam itself is a heat source. Think about a jacket.
Steam is not a heat source. Heat source is ash.
Yes, that's what it is. So think about a jacketed kettle. Do you think that's a clearation? Where's the fire? Where's the fire? The fire is through.
It's fire. The pasteurizer will be. The furnace is hot. The furnace is very hot on the.
And here the furnace is burning hot also. The steam. I'm not talking about the first 5 minutes, but once it's running, the thing is running at 175 degrees or 200 degrees for hours. Yeah, I don't mean the first minute, but with time, that's what's going on.
Pasteurizer will be a cliche.
So you're going to pour in water. Before you get to your side, let's not get any Kashering it. You're going to pour in water. When the juice comes in, you're going to pour in water.
I'm not even going to tell you. We'll get to that in a second. I'm going to talk about that. I just want to remind us that we officially are learning Aruch Gimel Dal, which is that I'm getting to that part. But the pieces are touching each other. Okay, there's a million pieces touching each other. Now we have a very unusual case over here, which is that the din says you now have kelim touching each other. Okay, but of course, if kelim touched each other when they became treif, and you hold them in exactly the same position when you want to catch them, that's okay. If they were like this when they became treif, because if let's say they were like this when they became treif, okay, and now I put them into the hagol exactly in that same position. So what you're saying to me, the place where they're touching each other, the hagol doesn't touch it.
So what that has a chalol on it?
Right. We talked about this by the handle. The Ramah says when you have a pot handle. So he says like this: the pot handle, the handle doesn't touch the hagol. If you don't put the handle in, if you just catch the frying pan and not the handle, it's not going to get in. So the me'ikar hadin. I remember we argued about this then. Me'ikar hadin. The blia went in from the pot into the handle, and when you catch the pot, kabbalah kaspolta. Just like the blia went in from the pot into the handle, if you catch the pot, it draws the blia out of the handle also. The only reason the Ramah is mashma that you have to catch the handle is because things might spritz onto it. So then the bleed didn't go in straight.
No, it's because it goes down through also. This should be the same. 2 reasons.
Right.
That you just said, and because it goes in through the thing. And then we have to catch the handle also because of.
Okay, we'll go back because we argued about demos. So if the camel, okay, so in my mind, if the camel are touching each other, the spot where they're touching each other, the Kabbalah Kapot that says if the blia went in when they were holding exactly this position, so the blia went in through this into the spot where they touch, so then the blia is going to come out through this on the spot.
Do you think there's not going to be any water between the two things?
No, in any places where they're touching, where there's no liquid. Water can't get in, so they can't drape it up that way. Right. If they're touching so solidly that water doesn't get in, so then the blia went where the blia went in. That's the way the blia is going to come out. That doesn't bother me. But what bothers me is that the packing doesn't stay still. Okay, the packing, the way the person they explain to you.
The first method.
The random packing, right? These pieces they don't stay still, right. Which is to say, the person said to me, says when you fill this thing up. Okay, the first time you fill it up, the packing will go to, let's say, an inch below the thing that spritzes out the liquid. Okay, the spreader they call it. The thing that spritzes out the liquid. If you come back 6 months later, it's 3 inches below that thing. Okay, in other words, what happens is now he says it's usually at the beginning. There's a lot of settling, as you can imagine. There's a million pieces of Lego, so with time they find their spots. So after a couple of months, they're settled into position and they don't move very much. But he did say, especially when you start it up and when you finish it off, there's a little jiggling around. And as you think about it, you're starting with it's just sitting there nice and cold, and all of a sudden you start blowing steam into it, so there's a certain amount of jiggling around. So the question is going to be, well, if they jiggle around, means today it became shaped like this, and tomorrow it moved a little bit like this. Now there are spots that are going to be covered that weren't covered yesterday. So how are you going to kasher the thing?
Well, you do the same thing like Kashering.
Which is what?
You do like a few times, they'll jiggle around, so eventually every spot will...
So you have to, okay, maybe you could say that, but you really have to be a navi to say you're going to figure out how many times to do it to get every piece to move exactly. You know, they don't move in concert. This is not like, you know, everybody move over 2 steps.
You're right, but 2, 3 times, 3, 4 times.
So you think you'll probably cover yourself.
Yeah.
Okay. I would rather say, I'm not through what I'm going to tell you either, which is that it becomes a cliche also Stam Shpeshefa. I mean, how many spots are you missing?
Okay.
Let's not answer the first question. How many spots did you miss? Of 10,000 pieces, there's 3 little spots here, and here that moved last time that didn't get caught this time. So maybe those little pieces we can just
ignore. What's the practical application that you have to kasher?
Oh, what's the practical application? If you want to go from let's say grape juice and apple juice. Grape juice and apple juice are processed in the same kind of kalim, and you're getting the essence. You concentrate both of them. When you concentrate, you take that liquid, and 5 feet away, someone's going to be recovering the essence.
It's typical from grape juice.
Yeah, grape juice and apple juice are very common.
One fatty acids.
Well, in fact, no. In fatty acids, it is common also. They use this kind of kalim. It's not so common that people want to kasher them, okay? Because it's a real nightmare to try to kasher them. Okay, and that brings us,
very, very dirty anyway.
which brings us to the other part, which is
you're going to do that clean.
That's where we're headed to, which is these kind of things that are set up. They set up a distillation column for petroleum or for apple essence or for fatty acids, whatever you're doing it for. The things are such dedicated equipment that you use it basically for the same stuff all day long. I mean, if you're doing apple juice, you don't all of a sudden start doing, deodorizing vegetable oil. Doesn't look like that. Your deodorizer, that's your deodorizer. So your fatty acids, you do your fractioning of fatty acids. You might take off different fractions. You might you might put in different liquids. You might put in coconut oil today and animal fat tomorrow. But if it's for fractionating fatty acids, that's what it is. It's doing like that. But because it does basically the same stuff all the time, and especially because the fractionator, or the distillation column, is really a purification system. It says, I'm going to get the thing to be at exactly the right boiling temperature. I'm only going to get up what I want to. So if I put in animal fat today, and I put in vegetable oil tomorrow, I'm not worried about contamination one from the other, because even though animal fat and vegetable oil are not the same thing, but the part, what they call the fraction that I'm taking off, is going to get exactly the thing that I want. If I want to get a C16s out of this thing, I'm going to get only C16s. At this part of the column, I only get a C16s. So it's not a matter of contamination. I'm not worried about there's going to be an animal piece to it, or animal, who knows what, mixed into this thing, because I'm getting off C16, and it's a very sophisticated thing. I'm getting just what I want to. So what do I care from one or the other one? So they don't feel any need to clean between one and the other. Okay, when I watched the guy doing this with juice essence, I said to him, how do you separate between one juice and the next juice? What do you do to separate between them? So he said, well, when we finish one juice, we start running the next juice through. As soon as we finish, let's say we finish apple juice, we start running grape juice. And we send the guy upstairs. Okay, and at first, the stuff that's coming out smells like apple juice. When it starts to smell like, and that stuff we throw out because we don't want that. We're starting grape juice now. When it starts to smell like grape juice, then we start recovering it. Okay, that's what it is. You can't believe it.
Very scientific.
Yeah, it's like, in other words, basically, we know that it takes 10, 15 minutes. So 15 minutes after we started, we send the guy up. The first 15 minutes, we drain the stuff. Then we send the guy, it smells like grape juice. We're in business. So cleaning was like not even, you should clean the stuff. Because, again, this system is meant to purify things. That's its goal. What it does is it separates little pieces out of what you want. So it's purifies. So who cares if there's a little grape juice mixed in? Doesn't mean anything. It's not grape juice. It's the water that came off of grape juice. But who cares? And then in places with oils and fats, those things don't spoil, and they just go on and on and on forever. Guys who have tried to clean deodorizers, I heard the horror stories of what happened when they opened the thing up. Companies went from trace to kosher. So all of a sudden, they wanted to catch it. They opened the deodorizer, and the thing had a year's worth of fat caked onto the thing. So those are like a horror to try to catch it. But in the simpler cases, like juices, where it's really just water pouring through. When you're concentrating this, you're taking water that has a little essence mixed in, so it's probably pretty clean. But how do you even know that you got all the liquid out of it? Think about what's going on.
Deodorizer is the same thing as distillation columns?
Yeah, because the deodorizer, what you're doing is you're distilling out the smell. Okay, you're distilling out the parts of the smell that you don't like.
Right.
You get them. You're not catching them. You're just letting them go out to describe your cat. There, what you want to get rid of something instead of want to catch something. But let's say even in the place that's making juice essence, okay, the liquid that's pouring through, there's water pouring through this. Okay, so imagine if we had 10,000 of these pieces stacked on top of each other, and we turn the machine on. Okay, we come back 24 hours later to Kasher. Okay, you think it's going to be dry? You think that the thing is going to be there's going to be no liquid in it? Of course, there's going to be liquid. Imagine taking 100 pieces of Lego, putting them into the bath, and then letting them see if they get dry. So who knows how long it takes to get dry? So how do you even know that you got the liquid out of there? Even in water, it's easy to clean them. There's no problem to clean it, but this is not easy to clean. It's not a stainless steel container. You just hose it down. Because the whole point of this thing is to make 1 million surfaces on it. Then how in the world are you going to get this thing clean? Okay. Now the other side of the problem is now that you decided somehow that you got all the be'en out. Somehow you got all the be'en out of this thing. How are you going to catch it? So the first thing I said to the guys, no problem. There you go. We'll just fill it up with water. It's got steam in the bottom. We'll fill it up with water. Right? Big expense, we can fill it up with water and boil the whole thing up. And they laughed at me because they said the thing on the bottom that holds this packing is something holding it up, some kind of it's called a bed limiter. Okay? It limits the bed, right? It holds up the bed. That thing is strong enough to hold up 10,000 pieces of Lego. Okay, but if you filled it with water, okay, the thing would collapse under its weight. It couldn't handle the weight of putting so much stuff into there. It's not meant for that. So you can't fill the thing up. Some of them maybe you can. I can't say that none of them, but as it's not a simple thing to fill it up with water. So how are you going to catch this thing?
Well, usually when I get the juice, it's bursting relatively slow.
Even if it pours very quickly, it doesn't fill up. The point is, you put 100 gallons a minute, but
why it starts whatever.
No, and whatever comes to the bottom gets drained out. But you're trying to get it to dribble through the pieces, but what comes out the bottom, I mean, there's a relatively small amount at every time. So even if you figure out how to get the end out, how are you going to catch this thing? Okay, so I have to say what people do is it's a bitachon kind of a thing here, which is they say is, what does the company do to start this machine up? Okay, what they do is the way they start the machine up is when it's cold. What they do is they run the machine just straight steam. They'll just put steam onto it until they get it nice and hot. And then they'll maybe run some water through it, some just plain water will be run through it just to get it going, just to get the process flowing, everything running the way it's supposed to. And then they'll start up with the juice until they send the guy upstairs to smell that it smells like apple juice. Okay, so when they tell people kasher, they say wait for it to be any beyamer, turn the thing on, let some water run through it, and put the steam on and hope for the best. Okay, and
this Kashering with water or Kashering with steam?
So now you can view it how you want to. Probably
they try to Kasher with water. Why not send in steam? That's
probably the safest way to kasher it. You can't kasher with steam, but what you can do is steam that condenses and turns into water can be used to kasher. So if you ran straight steam in the machine, you would probably get a fair amount of condensation, right? And that would be water that could be used for hakolah. But you have to have nevuah to know that you got it on every surface. In other words, you're pumping steam into a thing with a zillions miles of surface into it, and how do you know that you hit every area? I mean, maybe a chemist, an engineer could figure out how you know when you hit every area, but it's really guesswork. Okay, that's even assuming you got all the end out. I don't even know how you get. How do you convince yourself that? I guess you can flush it with water. Let it run for 2 hours with water.
Did anybody ever check to see if they got the band out?
Well, no.
You can't open it up, look through the thing?
Maybe you can. I don't know. Maybe someone has checked. Okay. I would be nervous that even if it's sat for a long time, how are you going to get? Imagine this thing full. Imagine someone gave a shake to this thing afterwards. How many drops of liquid are going to come pouring out? So maybe you could just pour a lot of water through it and hope that flushes it out. But the Kashering bothers me more, which is how are you going to make sure you get hagolah water on every surface? Now, during production, it ran for 10 hours straight. By that point, every spot has been hit. We talked about when the pieces touch each other, how much space is not getting touched. So there's a little spot where it moves over. Okay, we had a little spot we could say it's uslush shamash b'sheva. But when you're going to catch, you're going to pump up steam. So how are you going to hit every spot? You know what I mean? When you have trays, that's easier. The trays are, we talk about having trays and things. It's easy. The trays, it's just one spot, so you pour water on, and it runs over every tray, and you'll kasher it. I mean, you could be comfortable if you ran it for long enough that you kasher it. That wouldn't bother me. But when you have packing like this, or even the structured packing, the pieces, that are not random like this, there's still lots of surface to this thing. So I'm not very convinced that it works. And Baruch Hashem for Ein Binyamin, and for Stam Yain, we know usually it's not a you have to kasher it. Well, if the stam yain, this stuff mamish held just stam yain, just from stam yain to apple juice. Because the bleeds of stam yain all scum. So it just.
I mean, this is hot.
So.
When did I tell you we say that?
I don't know if that's true. Bleeds of stam yain? I don't know.
What do you mean tiny? Only by
What's the
color?
difference? I don't know what's the difference. What's the difference? It's a reflection of the blia. I don't think it's only for.
I could hear you don't have to cash any for any grape juice that pasteurizer.
Well, we've talked. Maybe yes, maybe not. What's the difference? What's the difference of the blia if it's hot, if it's cold? Okay, we can look at that. I don't remember. Okay, but it's well. Okay, so then if you don't like that, I'll try a different one on you. But by stam yain, it's built of shisha. That's also good for the Jews, also. Usually, I have to tell you, usually the people who are doing this with like oil distillation and fancy stuff like that, it's much more sophisticated what goes on between treif and kosher. People don't switch back and forth. There's like no such thing as switching back and forth. And if someone's going to kasher, the mom is going to take the thing apart and open it up and take it very seriously. As opposed to like in Jewish kind of things, they go back and forth. This is reasonably common to go back and forth from one essence to the other. And most people just say the way they call it is that it's self-kashering. You just turn on the machine and the startup procedure starts kashering, and it's very not clear. It's very not clear for a whole bunch of these reasons. You don't know if you got rid of the end. You don't know surfaces are touching, and most importantly, you don't even know that the Hagala would touch every spot on it.
So, anyway, helps for band. It was band part of the unit. There's a little bit of band.
So it'll be us for challenge for chef also, or it'll be bottle. Okay, so all of that.
It ain't even possible to get away with it.
Well, I mean, all of that doesn't make me really thrilled to eat my apple juice, but whatever.